Floodplains worldwide move several tons of sediment per year, but what are they? Nansen and Croak defines a floodplain as a surface next to the channel that is inundated once during a given return period. But how did the sediment get there in the first place? There are several different floodplain depositional processes, the main two being vertical accretion and within-channel accretion. Vertical accretion happens mainly along low-gradient, single-thread or anastomosing channels. This mostly happens in places with low energy within the stream, resulting in little to no channel migration. This can look differently according to what kind of river processes are occurring within the floodplain. For example, floodplains with a levee and back swamp rely heavily on overbank flow within the vertical accretion process. As this overland flow occurs, sediment is deposited onto the floodplain and distal fining happens. In an alluvial, multi-channeled system, such as landscapes with a secondary channel, water floods the area between this and the primary channel, leading to the buildup of sediment in the middle. And in an alluvial, meandering system, this overland flow spills into an abandoned channel located next to the primary channel. Within-channel accretion is a combination of several processes. First off, we have primary channels shifting to allow stabilization of past active braid bar areas and riverbeds. This within-channel accretion is responsible for about 60 to 90% of all material within a given floodplain area. This happens because of a helicoidal flow, slowly moving sediment over the scroll bar, resulting in concave bank accretion and the creation of lateral accretion structures. The occurrence of these mechanisms can change depending on the location, and the rate at which they happen changes based on the energy of the system. There are three energy categories: high, medium, and low. High energy systems have an energy of more than 300 watts per meter squared. This happens mainly in valleys with a high slope and confined or partly confined valleys. Medium energy systems sit at an energy between 10 and 300 watts per meter squared, and are commonly associated with braided and meandering rivers. Anastomosing rivers are the main type within the low energy category, with an energy of under 10 watts per meter squared. Floodplain stripping involves the reworking and stripping of the floodplain. This occurs in four main steps. The process begins with a stripped landscape, and over time, the amount of sediment builds up, leading to a more mature slope. Eventually, a larger scale flood event occurs, leading to mass erosion, effectively resetting the system and reverting back to step one.